right, this lesson is on section 2.2, where we're going to talk about what a function is. A function is a relation, so it's just a relationship between two sets, x's and y's. We know that, where the x's have to be different. All right, so the x coordinates must be different. If the x's are different, they don't repeat, then you've got a function. And to review, the first set is called the domain, or set of inputs, or x coordinates, or independent variables. And the second set is called the range, or the set of outputs, or y coordinates, or dependent variables. So since the x's have to be different, we can come up with a test. The graph of a function is a curve in the xy plane, but the question arises, which curves in the xy plane are graphs of functions? Well, we can get, if you're looking at a graph, the easiest way to make sure the x's are different is by using something called the vertical line test. Okay, so a graph represents a function if and only if it passes the vertical line test. Every vertical line intersects the graph at most once, just once, because the x's have to be different. So here, if I draw vertical lines, a lot of times teachers will say you can pass your pencil through and it only intersects, every vertical line you could draw only intersects the graph one time, then it passes the vertical line test. That shows you that all the x's are different. So that passes the vertical line test, so that is a function. But see, this one you can see it, if you have one vertical line to show your example, you can see that this graph is crossing through this vertical line two places, and so that x is repeating itself. So if this is a here's A, and it's at C, well, this is also at A, and it's at a different point B, and so the x's aren't different, they repeat. So this A is going to a y coordinate B and C, so that fails a vertical line test, and that's not a function. Okay, so here we have some examples. You can go ahead and pause and see if you know which ones are functions or not. These are relations, but not all of them are functions. Right? This one, no, it fails the vertical line test. This one, if you pass through all of it with a vertical line, that passes the vertical line test, so that is a function. This V is also a function, but this one fails the vertical line test, so that is not a function. Right, and then this is a list of functions that you need to know what they look like and how they are written. So this first one, y equals f of x equals mx plus b, that is any diagonal line. If you just have y equals k, then that's a horizontal line. So lines are function, except for if you have x equals a number, like x equals 4, that is a vertical line through 4, and that is not a function. So that is not a function, but every other case is. Polynomial functions, they are always in the form of x to some power. Some of these polynomials you should know, like y equals x squared, that is a very common U-shaped graph. That's a parabola or quadratic function. So the graph is called a parabola. And y equals x cubed, that's another polynomial. That is going to look like this. So if you have an odd degree, the ends go in opposite directions. So that 3 is an odd degree. We've talked about square root functions, any kind of root function. This is a square root function here. So a square root function is if you have y equals the square root of x, which means the index is 2, and it looks like this, which makes sense because we know, we've learned about domain, we know that for square root of x, x has to be greater than or equal to 0, so that's why it looks like just a starburst. But this is an odd square root, odd radical function, f of x equals the cube root of x. It's odd to remember that domain is negative infinity to infinity because we don't care if it's an odd index. You can have negatives and positives in there. So that's why it looks like this. It's defined for all the x's. There is no restriction on the domain. All right, we can talk about rational functions. So a rational function looks like something like this. It might be x minus 2 over x plus 4. And remember, we don't care about the top, but the domain, the denominator, it can't be negative 4. So that's going to show up as a vertical asymptote. So here's what rational functions will look like. If you have a variable in the bottom, it's a rational function. Here's another one. And this is 1 over x. And you can see x can't be 0. And you can see there's a vertical asymptote right there. And there's also a horizontal asymptote because there's nothing that can make that go to 0. So you have these branches. So whenever you have these like two branches like this, and they seem to be hugging these lines called asymptotes, that's a rational function. You can even have 1 over x squared. That square keeps that output. It keeps that output positive. So you still have vertical asymptote, but your branches are both on the positive side of the x-axis. And then we have exponential functions. So like y equals 2 to the x would be growth. So that would be something like right here. Let's put that right here. So if we had y equals 2 to the x, as x gets bigger, y gets bigger because that's growth. And there's a horizontal asymptote. So exponential functions look like backwards j's, or this would be y equals 1/2 to the x, for example, or j's. So exponential functions have that j shape, backwards j or regular j shape, and they have horizontal asymptotes. And then lastly, the absolute value, it's kind of nice, there's a v in there for absolute value. They are in the form of v. So these are all just special functions that you need to know on site, and you need to know what the equations look like. So take a minute to study that.